We are at the Data Center Dynamics event in Madrid with Dr. Sander Otte, associate professor of physics at Delft, University of Technology in the Netherlands. In your conference, you are going to talk about the atomic hard disk as an alternative for storage in the data center. Why is it necessary to think about an alternative?
So if you look at current data storage technologies like the hard disk drives and flash drives and these kind of things, they become smaller, but it's always a miniaturization of existing technology. So you have an existing technology that you make smaller and smaller. That works very well up to a certain limit, because at some point the materials you use will reach the atomic scale, and then you can no longer continue to reduce the current technology. The only way to really store data on the scale of the atoms is by actually moving the individual atoms themselves and positioning them where you want. Mm-hmm. And that's exactly what we do in this technology.
Because it's true that when we talk about IT equipment, companies are been working on the size of IT equipment,
right.
Making them smaller and smaller, but above all, servers and chips. Are they doing something similar in storage?
Absolutely. I mean, storage has been getting smaller and smaller over the years. However, we are already noticing that things are leveling off, because you can no longer make the grains on hard drives, for example, smaller, because they will lose their magnetic stability if you do so. We have reached what is called the paramagnetic limit for that. So then there's other techniques, like I think there's parallel storage, and there are several ways to do it. But we are reaching the limits of existing technology. And therefore it's good to look into possibilities that go far beyond that. So what we do is not an extension of existing technology. We really start all the way from the bottom up. We start with the smallest building blocks that nature has to offer, namely the individual atoms, and we try to store data really in one atom per bit.
Okay, and what are the possibilities of the atomic hard disk? What is your project about?
Right, exactly. So in our project we are able to position many atoms, 10,000s of atoms, where each bit is represented by a single atom. So you can reach an amazing storage density in theory. Now I have to say that that technology is currently really on a lab scale, right? We are very far away from actual implementations of this, and I think there are severe barriers for getting to a true atomic scale hard disk on a large scale. However, I do believe that this technology could be possible, not necessarily only for data storage, but also for the possibility to make circuits, to make devices that are with an atomic precision. And then you can, for example, think about existing transistors, existing electronics built on a true atomic scale. And I think we're going in that direction, and our research is certainly a step into that direction.
How can the atomic hard disk help improve the efficiency and performance in the data center?
Right, so, well, atoms are much smaller than the current bits, right? So the data storage that we have achieved is in theory 500 terabits per square inch, which is a factor of 500 better than the best storage technologies currently available. So it would be much more efficient in terms of scale, of size. Now, if you would implement this in a data center, not only would you use much less space to store the same amount of data, I think it can also be much more efficient in terms of power consumption. Because if you really only need to move one atom to store a bit, you are much more efficient in terms of power than when you need to charge a capacitor in a flash memory, for example. That's why flash gets hot, right? So I think both in terms of scale and in terms of energy consumption, this could be more efficient.
Okay, and has this technology been deployed in some kind of infrastructure yet?
Not at all. No, I really want to emphasize that what we do is currently very much on a lab scale level, and we are far from reaching true industrial implementation. However, I do think that we are reaching a stage where we can take this research out of the academic labs and more into an industrial research and development setting, because we have shown that it's actually not that hard to do this, right? If given the right ingredients. And I think it is time to make a bigger step now forward to develop this.
Yes. And when do you think it will be possible to see this kind of technology in data centers, in industrial sector?
Well, I'd like to be very careful there. it will all depend on to what extent this can be now taken out of the academic level and really into a larger R&D level, and then in what form or shape that will ever reach true applications is very hard to predict, and also when. We are certainly talking 10-20 years, but probably longer. But I want to say it is very long term. But it's also extremely fascinating, right? We are reaching now the age in which we can think about adjusting the world on the atomic scale, and that is fantastic, right? So without thinking about applications and making profit of it, let's forget about that for a moment. Let's think about the possibilities, and they are truly amazing and intriguing and fun. And that's the message I would like to convey today.
Yes, and you have been talking about possibilities, but what are the challenges when deploying this kind of technology?
So one of the biggest challenges is, well, there's several. So first of all, when you want to position individual atoms, it is very important that the surface that you do this on is atomically clean. So there should be no foreign atoms, no oxygen, for example, should be flying around, no water, because it will destroy your memory. So it needs to be in vacuum, and this is one challenge. Anything you do this way has to be in a very clean vacuum chamber. Second, it needs to be at very low temperatures, because otherwise, if you increase the temperature, atoms will start to move around by themselves, and you lose your data. So it has to be cooled to temperatures that are close to the absolute zero point. Now, both of these requirements are somewhat difficult, but still doable, right? You can think of large-scale data center facilities that are both in vacuum and very cooled. But there's a third requirement that is actually, I think, the most severe one at this stage, which is that you need extreme stability, for mechanical stability, to be able to control the position of individual atoms. And if you want to create it on a large scale, you want to make some device that can be very precise in positioning an atom, but can also travel relatively long distances. And that is actually something that is very difficult to make. So we would have to come up with a completely new design to do that on a larger scale.
But apart from these challenges, is it possible to use atomic hard disks?
It is possible. Yeah, we've shown it is possible on a kilobyte scale, and without much modification, but with just more effort, we could easily go to the megabyte scale and even further. But if you really want to get something useful, like terabyte scale, right? Then you need to come up with new adjustments, but no new fundamental physics, right? From this point on, it's all engineering, and it is possible. Yes.
Sometimes the data center industry is very reluctant to adopt new technologies until they are proven, you know. And talking about 20 years ahead or so, do you think they will be willing to adopt this kind of technology?
Well, the thing is, I think it is a bit of a problem with the current day and age, let's say, that companies have a fairly short horizon, and that's a pity, because if you look back a few decades, there were companies that actually were investing in much longer term research with a much more uncertain horizon, but potentially much bigger yield in the end. And I would encourage companies to be confident and take that step. Not only my research, but in general. Right? Think about the long term, about the possibilities. We have resources and money to spare. Let's do it, because on the long term we can really benefit. The last 50 years, we have seen a tremendous improvement in all our technology, but it's mostly been just a reduction of technology that was started in the 1950s, right? And just smaller. We are reaching the limits. We cannot continue to do it this way, so we need to look over the barrier and look into a new direction where you really start with atomic scale precision. And I want to encourage people to indeed adopt that.
Yeah, and the point is that energy efficiency is key nowadays.
Absolutely.
Yes, and we don't know in 10 years or in 20 years how the situation is going to be. Maybe the energy efficiency is going to be even more important.
Absolutely. It's the most important problem we have at this moment as humans. And if there's any way we can try to solve that, we should do it. Yeah.
Okay. So thank you very much for your collaboration. It was very interesting.
Thank you.
Thank you so much, Dr. Sander.